Hello everyone, this is Meedhansh and welcome back to the Java series. Today we are going to cover the topic for classes, objects and references, where we will know a lot more things about the structure of the classes, how do we create the objects, and we will play around with the objects and the references as well. So let's dive right into our topic. Okay, so here's our screen, and today we are not just gonna do the presentation, but instead we are going to do the practicals, and we are also going to understand with the help of the diagrams that how the classes, objects and references work. So let us initiate. Now first of all, I will create a class over here which will be a public class. So it will be public class. Let us keep the name demonstrate. So demonstrate is the name of our class and we will save it. So I have already created a folder and I have named it Java YT for you. So now the name of the file must be the same as the name of the class which is given in the file. So over here we have the demonstrate.java. And now the keywords are in their proper color. So this is the class in which we are going to demonstrate all our activities which we are going to do further in this series. So we will begin with our first one, which is the classes, objects and references. So we have a main method in every Java program which is the initiator of the whole program. So it's the basic, which is public static void main. It is the main method and hence it is named as main. And we pass an array known as args. We can give it another name, maybe A or A or G. It can be anything, and it's a array of string. As we learned in the class of data types, so string is a special data type and we have an array for this as well. Array is an ADT, a high level structure. So we will cover that later. For now, we have this main method ready. A demo. Let us just have a demo for it first. So we will simply print the hello world, so that we know that our class is working or not. And this was the code for everything. Now we will go to our command prompt. I will change the directory to D, to the volume D, and then I have the folder named Java YT. Now, as I talked in the second class where the installation, I talked about the installation. So over there I talked about two commands which are javac and java. So javac is the compiler and the java is for running the program. So first we will compile the program, which is javac demonstrate.java, and it will take a little bit time, 2-3 seconds, and if there is no error, so it will simply just reprint the statement that d:/java yt or whatever the name of your directory is. So it means there are no errors while compilation. It depends, the error can be on the compilation, and sometimes when we run the program, at that time we get the error. So for now there is no error. Now Java demonstrate. Now why I am not writing here .java or anything else is because first we got the value. Now let me show you that in this folder we have, it's an old file demo.java. So over here we have the demonstrate.class. Now this is the bytecode which was created automatically by the javac command, and this bytecode automatically gets picked up when I simply write java demonstrate. And this is how it works simply, and I will take it in a bit more explanation in the further classes. So for now let us just understand the basics concepts. So first we created the file demonstrate.java and then we created the and that it automatically created the demonstrate.class, which is the bytecode. And when I run the command java demonstrate or whatever the name of the file is, so we get the output hello world. This means that our whole program is working. Let me just clear the screen. And now going back to our notepad. Now I am doing a clean code over here that I will keep the main method separate and the place where we are going to create a new class will be separate file. So I create a new file and I will give the name over here class temp for temporary, let's say. But I am not giving public over here because I will not include the main method in this class, because I have already created the main method in the demonstrate and we are going to create the objects of this class in the demonstrate class. So first we will save it. So it is temp.java. And here are some naming conventions, like for the class I have the first letter capital, and if there are, let's say, two words like my temp, so M will be also capital and T will be also capital. Whereas for the methods and the variables or attributes, we have just the first letter small and then rest of all the words with the first letter capital. So we have the class temp, and we will just create a simple function over here or method. So public void show. We will simply write over here system.out.println, and let us print that hi, it's the show method. We can print anything over here. So I have printed the hi, it's show method to check if it is working. So I have saved it and now we will compile the file. So java c temp.java and it compiled. But now if I try to run this file java temp, so it will give me an error that the main method not found in the class temp. Please define the main method as follows. So the way we defined it, the public static void main and then string array and the name args, or a JavaFX application must extend. So it is the error which we will get if that particular class does not contain the main method. But we are not going to create the main method in this class, so we are not going to run this class either. Let's go back to the notepad. So now for creating an instance or an object of a class, we have the new keyword. So as the name of the class which we want to create the object of, it is the temp. So temp, let's say t1 is equal to new temp. So now an object will be created for this particular class. Now before we execute this statement and we draw some diagrams related to it, first let us see that how does a really simple literal works. Like here it will be a literal. Now if this is the literal value, let's say a is equal to 100. So how will it work? Like, or if we put over here the int a is equal to 100. So how will this statement work? So the way it will work is that firstly it is basically a three-step process. So the main rule of thumb is that everything in programming or every assignment, we can say every statement goes from right to left. I mentioned it in the operators as well. So every statement goes from the right towards the left. It is being initiated the other way. So first of all, on the right side we have a number which is 100, and this number will be created in, let's say we will create a memory map over here. My drawing is not so good on the computer, but still. So we will create the 100 in a buffer. So it is basically a buffer. And now in this buffer, basically buffer is the temporary value container in the memory which stores a value, and then it gets destroyed automatically once the value is not assigned. So the value we have is 100. So over here 100 will be stored in the buffer. Now we will not move on to the equal to, but now we will go to the extreme left, and on the left side we have a variable, an integer variable named a. So now again in the memory we will get a variable a or a container. Let me just use the shapes for better understanding. So yes, so we will have a variable a in the memory. This is the memory map over here. Memory in the sense the RAM. So everything is being stored in the RAM. And now basically it occupied its space. And how many bytes does it occupy? It occupies 4 bytes, because as we studied, so int occupies 4 bytes, byte occupies 1, short 2, and then long for 8. So int over here is occupying 4 bytes in the memory. And the third step is this equal to sign. So what will this equal to sign do is that it will copy this value in the buffer to the variable, and this value will be now copied to the a variable. So we get the value a 100 over here in the a variable. So therefore it is a 3-step execution or a 3-step process. Alright, so since we understood that how a is equal to 100 works, so now the same way we are going to know about the other one, which was this temp t1 is equal to new temp. So now we will start from the right. So the execution works from the right towards the left, and this new keyword over here is for making the object. So to create a new object in the memory, we use this new keyword. And for which class are we creating the object? For this class, which is temp. So let's go back to the pane, and over here now we will have a memory map again, and on this side we have this statement temp t1 is equal to new temp. This new create the object, so new temp, brackets and semicolon. So we have to execute this statement temp t1 is equal to new temp. So how will it work? It will work towards the left, from the right towards the left. So the way we did a is equal to 100, same way we will do this execution. So first of all we will create an object for the temp class. So I will represent the object as a circle in the memory. So this is an object created over here, and it has some name. Well, not the name, but it has some address as the identification in the memory. So let's say its address is 1000. It is not 1000 exactly for the objects in the memory. The mostly the addresses are in the form of the hexadecimal, and it's around a 6 to 7 digit address. But over here, just for the understanding, we have 1000 as our address for this particular object. Now going towards the extreme left, this statement temp t1. What is temp over here? It is the, we can say ADT, or we can say it is a customized data type. And if I ask you what is t1, so most of you might be thinking that it is an object or it represents as an object, but this is not true. Object is just this part from new temp. This is the statement which creates an object, but this statement over here towards the left of the assignment operator It is just the reference variable which we discussed in the data types. So this is the reference variable for the class temp, and the name of the reference variable is t1. The way we have a and the data type, let's say we have the int or anything, byte, short, anything. So int a. So a is the name of the variable and this is the data type and this is the value we are assigning using the assignment operator. So this is the whole process. So now we initiated the first step, which is towards the right, and this we created an object. Now we will create this reference variable in the memory. So this is, let's say, our t1. Now what is this doing over here? The assignment operator. It is not assigning the object, like it is not carrying this whole object to this t1. No, this is not possible. Like an object is not being stored in t1. But actually, as I discussed for the address, this address is going to be copied. This reference variable, basically this address is being copied to the reference variable first. So this is going to the reference variable. This address, which is 1000, is being copied to the t1. So t1, the value stored is 1000 or the address of the object. Now this t1 variable is referring to this object, the object which we created, new temp, and now this object is assigned to the t1. So this is how this statement works, and this is the process which takes place in the memory. And now let's say we create an other object which is temp t2 is equal to new temp. Now again the same thing, we have an other object over here. We don't have enough space, so I'll just create it a little smaller, and it also has its own address, and its address is, let's say, 1000, let's say 300 is the address for this object, this particular object over here. And now the second step is to create the reference variable. So we have the name temp t2. Now again the same process, this address is being copied to the t2. So this is the process of copying which is taking place over here. So this address, let me just mention that I should mention it here. So 1000 and 1300, that is 1300, are the addresses where the objects are stored. Just as simple as that. Let us take an example of a house. Every house has its own number known as house number, and we identify that house using its number. It is a unique identification for that particular house, and that house might be situated in a colony or anything else. So it can be a colony, it can be, let's say, if they are flats, so we have the flat number and then a particular place or the particular place where the person lives. So 100, 101, 102. So the same way we can call them as house, and they have their own address. So every house has an address and a house number. So the same way, this is the address for this particular house, or we can say the object, and this address is being copied to t2 now. So 1300. And now what next is happening? The t2 now refers to this particular object which we have created over here. So now both of our statements, we have executed them, and let us see what we get the output. So if you are curious to know that how the address actually looks like, so I can just simply print the address So we were using the println. So let's say T1. We will print the address for the T1. So let's go to the command prompt, and we have to compile our file again and again. So we have the file demonstrate.java. Remember to put the Java over here, not necessary in the next statement. Demonstrate, simply Java demonstrate. And this is the address we got. So the temp, it is the class name, and basically it is telling that which class's object is it. So temp at the rate 2F92E0F4. So how many digits? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 digits for this address, and this is definitely a hexadecimal to F because the value is not exceeding from F. So this is the representation in the hexadecimal. If we convert this hexadecimal, it will be a huge binary. So you can just imagine where our object is stored. So yes, it is working successfully. We got no errors, and we also saw how an address looks like. What we can do next is that I will create a new statement over here, which will be temp. Let's say just new temp. Now what do you think? Will it work? You might be thinking that no, it will not work, or it will just be created and nothing else will happen, or it might produce an error because we have not given it a particular reference variable. But actually this statement will work successfully. So let's go back to our memory map, and here we will get a new object created. It's just touching. Okay, well, let's just create it over here. Yes, this is the object we created using the statement new temp. This object will be created when we run the program, and then the moment it is created, since it is referenceless, so it will be destroyed because it has nothing to do. It has no work because in the temp class we although initiated a show method, but we haven't used it yet. So this method has nothing to do and it will just simply get destroyed. And who destroys them? Basically we have a destructor over here, or we can say, since we can call it as garbage in the memory because it is just occupying space for no reason. So it will be destroyed and the memory will be released. So for releasing that memory in Java, we have a automated inbuilt program which is known as garbage collector, also known as GC in short, because it saves memory for us, right? So it's the garbage collector or GC, and this GC, the moment it finds that this particular object has no reference and it is doing nothing, so it will just simply attack that particular object and it will destroy it. In case of the C, C++, those traditional languages, we have the destructors. So we have to create the destructors by ourselves, which help us to collect this garbage present in the memory. But do you think that those objects are important, or can these objects play any role in our program? You might be thinking that why would they play a role, because they just created and they got destroyed. So these objects are mostly used in the industry, and if we are using those referenced ones, so they are a bit more time consuming and they are less efficient, because till the program is running, these objects will continue to occupy their space even after their work is done. So let us just get some work from them. They are just free till now. So we will T1, then the T2 dot show. So we got the method show, and this statement will work, and this will show us the value that we wrote. I think the hello, yes, hi, it's the show method. So this will be printed, and we are calling this particular method using the reference variable of this object. Now we go to this and we will just recompile the demonstrate once, and boom, we got the value. Hi, it's show method, and then again hi, it's the show method. So this way we got our work done. But even after they have done their work, and let's take an example of the T1. So this is being printed by the T1 reference variable, or the object is helping. So when it has already printed and now it's the turn for T2. So we are getting no other work from the T1 and it is free. So this object will still not be destroyed from the memory map, this particular object. So this will still not be destroyed and it will still be kept over here in the memory till the program ends. So that is why we use these objects, because they are more efficient, they do their work and they get destroyed. But you might be thinking, how do they do their work? Because it did its work using the reference variable, and the moment it gets referenceless, it will also be destroyed. But till the moment there is one reference variable minimum which is referring to this object, it will stay alive. But when it is referenceless, let's say the value for the T1 will get null, so it will be destroyed automatically. Let us see how we can get the work from these referenceless objects as well. So we created the object over here, and after these brackets we will write dot show. You might be thinking that how will this statement work? So we will just check it once, Java C demonstrate and Java demonstrate. So we got the value. The show method is called once again. So hi, it's the show method. So we are getting the value. But now let us see that how is it working. So first let us just repeat how was this working. So what was happening in this case, this particular object was being created, one object created using this new keyword, the object for temp is created, then a reference variable T1 is created, then the address is copied from the buffer, and I forgot to mention one thing, that this address is stored in the buffer. What happened? Yes. So this object is stored in the buffer for every single object. Like if this is the object, so it has its own value which was stored in the buffer, and this has the 1000 stored in the buffer, and from the buffer it gets copied to the T1, and the 1000 comes here and it starts referring, and then using the T1 we call the method dot show, brackets and semicolon. So this statement will show us the show method. But over here what's happening is that we wrote this statement, new temp and brackets, and before this the semicolon we are putting an other statement together, which is the function call dot show, again brackets and then semicolon. So now over here will not work from the right to left, but let us just start from the left, because there is no assignment happening over here. In the case of assignment we work like this, the right to left. So first an object is created over here, this is our object. So a new object is created for the temp class, and now what is happening is, even if it's referenceless, it still has an address. Let's say the address for this one was 1500 and it is stored in a buffer. In this case what we were doing is we then copy the value to a reference variable, and then this, with the help of this reference variable, we are calling the show method. But indirectly what we are doing is we are somewhat executing this statement, 1000.show, because what is T1 containing? The address, and using this address we move to that particular object and then for that object we check if the method is available, and if yes it is available, then we get the result, and in this case we call the method show and then we get the result. Now in this case we have this stored in buffer, but we are not copying it anywhere, and else what we are doing is we are directly doing this 1500.show. So we are calling it directly from the buffer. Let us take the name of the buffer B1, although it has nothing to do with us. Let us not interfere in the RAM, but for our understanding we take the buffer as B1, and then the B1.show is getting called. So this way these objects work, and the moment its work is done, it's destroyed and it releases the memory for us free to do anything else. So we will just peacefully remove this, and yes, it's done. Instead of GC we destroyed that object anyways. So this is how this statement will work, and these are very useful in the industry because they release the RAM memory and we can just continue working. So that is why these are used, and they do their work and then get destroyed. So these somewhat create a bubble effect, like a bubble gets created and get destroyed within the work it's done. Although bubble is not doing any work, but still it's just a bubble effect. Like if I do not add this statement over here dot show, then what will happen? An object will be created and then it will get destroyed by the GC, the garbage collector. Now what if I put this statement temp t3 not equal to nothing, a semicolon? What will happen? What will be the result for this according to you? Might be thinking that it will not work, that because we haven't assigned a particular object. But remember, if an object can be created without a reference, then a reference can also be created without an object being assigned. Now when we execute that statement, what will happen is that there will be a new variable created for the temp class, and we will have the name for it as the t3. Yes, and it's an empty reference variable. So it has the by default value as null. If we have stored nothing in it, no address, no nothing, so it will have the by default value null. So now if I try to do this t3.show, will it work? The answer is no, it will not work. It will definitely not work. Let's check what exception we get. On the compile time only we got this error. In the demonstrate Java on the line number 11, there's an error that the variable t3 might not have been initialized. Initialized because we haven't given it a value, we haven't copied any address to it. So we cannot call the show function because it is not initialized yet. And even if we try to print it, let's say system.out.println t3. Once again, let us just compile it. We got an error, the same error again on the line number 11, and it is variable t3 might not have been initialized. In this case, it was the println. But you might be thinking that why it didn't print null? Because it is not initialized according to the program. Although it has the value null, but null means not initialized, and thus it cannot show anything over there. So let us just remove this, or else we will get an error. Now what I can do is, let's say I write this statement instead of new temp, although we can write like this, new temp. So we broke down this statement into two. First we created a reference variable, then for that reference variable we created a new object. But we know how this works, and we executed it twice. So instead of this, let's add a little twist. I write over here t3 is equal to T1. Now what will happen? Let us check in the map again. So T1 over here, what we had in the T1, it is the 1000 value or the address for this object. It is the 1000. Now what I am doing is I wrote this statement, T3 is equal to T1. Again an assignment. So going from the right towards the left. Now from that T1 we are copying this value, which is the 1000, to T3. Let us create a dotted line over here as we are copying. Although we can create a solid one also, but just for the understanding, dotted are the copying and the solids are those which are being referred. And this value will now be copied to T3. What will happen next is T3 will now start to refer the something like this. It might be a little confusing, but due to the space, I had to do it like this. So now this is also referring to this object. Now remember, there's another rule. One reference variable cannot refer to multiple objects, but one object can be referred by multiple reference variables. This we have over here that one reference. So one reference is our, let's say, T1. So T1 cannot like refer this object and the other one as well, because there will be an ambiguity, because both of these objects have the show method. Now if I execute this statement T1.show, what will it do? Will it execute the show from this method or from this method? So to avoid this ambiguity, we cannot do this and we cannot assign two objects to one particular variable. And if we try to assign that, first we created the T1 is equal to new temp, and then we had a T2, then we assigned T1 is equal to T2. So we got the variable from the T2 to T1. So what is happening is it will just stop its connection or destroy this connection from here, and it will establish the connection with the other object. So T1 and T3, both of these are referring to the same object. Now if I say the T3.show, so it will initiate the method from this object only, and for this statement also it will be initiated from this object. So let's take a simple example. For example, there's a person, and a person can be referred by multiple names, Ajay also, and the other name Vijay as well. So if we say that Ajay turned 31 today, let's say it's his birthday today, so he turned 31. So Vijay is still 30? No, of course not. He is also now 31, because it's the same person with two names. So that same thing is happening over here. The object is the person and we have different names for that object, because how can we refer to this object using the name only? There's no other way. Like if I say new temp dot show, so it will not refer to this object, but it will create a new one and then it will show. So this is how this particular rule of thumb works. So now there is another statement. So if I write T1 is equal to null, what will happen now? I discussed it just right now that what can happen if we try to do this, but it's a little different from that. So let us now try to execute this statement, T1 is equal to null. So what will happen is that this value will now disappear from T1, or it will simply set to null. This value is now gone, and since this value is gone over here, so will it affect this object? No, it will not. So although This particular object will have now just a single reference, which is T3, and this a particular connection will now be destroyed. So it is no more referring because it has null value. Over here it is null. Since it is not referring anyone, so that particular object will not be affected until I write this statement as well. T3 is equal to null. If I now try to execute this statement as well, first we have executed this one. Now the T3 is equal to null. Now executing it. So again, this is the T3 over here, and we will just banish the value. Boom. So since now this also contains the null value and u double l null value, now this connection will also be gone. It will also vanish. And now, since this object is referenceless, it will also get destroyed. Same thing that happened with the referenceless one. And by the way, the referenceless object is also known as, or is termed as, the on the fly object. This is the name for the referenceless object which is over here, and it must not be here till now because it is now destroyed because it completed its work. And the only one still alive is the T2 object. T2 is the reference variable, and basically I try to refer that the object which is connected to T2 is still alive, but this one is also now destroyed and this one destroyed it. And if I try to write this T1.show now or T3.show, let's write all of them. We should include the T2 as well. Let's see what happens now. We will go to our command prompt cmd. Let's just remove everything. So java c, and it compiled, and now java demonstrate. We got an exception on the runtime now. We got to see this one as well. So in case of runtime, we got this exception, null pointer exception, because we defined it as null. So we got this value. So first let's see by its show method, it prints thrice. So let's see how it's working. First we created these two, T1 and T2, with their objects respectively. We showed and we got the output. So this one is from the T1 and this one is from T2. Now we created an on the fly object and we called the show method again. So this one is from the on the fly object. This call is from that method, the object. Now what we did next is we created a T3. T3 is equal to T1, but we didn't do anything. Let us try doing it. So T3 dot show. Let us just recompile and run it. Okay, now we got another call for the show, which is this one, because now the T3 is containing the T1. Should we print it for better understanding? Yes. So system.out.println T1 and system.out.println T2, and we cannot print T3 over here, so let's just take them a little down over here. Yes, and then system.out.println T3. Now let's check the values for all of them. Okay, we have saved the document. We will now once again do the compilation, and boom, we got the result. So what we got is we got the calls thrice as we discussed for this one, And then we got the value stored in the T1, which is 2F92E0F4. Then for the T2, T2 has a different one, 28A418FC. And now we have the T3. The T3 has the exact same address as the T2. It is 2F92E0F4. So it is the exact same value which is stored in T1, and then the same one was, since it was copied in this statement, T3 is equal to T1. So it was copied, and thus we got this value which was the same one. Now we got this call using which one? This is that particular reference variable. So it is t3.show. We showed using, basically we can indirectly say using the address of t1, but we copied it, so it is now independent. Even if we run this statement till this statement, we still have t3 alive. It does not affect the t3 because now t3 is independent. It got its own value and it was initialized over here earlier. And now we have the exception, which is exception in thread main java.lang.null pointer exception. So it says cannot invoke temp.show. Now see, that particular thing which we wrote t1.show, right? But how did we get the temp then? As I mentioned over here, that this statement would something be like this, or we can say it is something like this. Actually it is temp.show. The correct statement is temp.show. So t1 is since null and it is known as local one over there. So since it is null, so we cannot invoke the temp.show, and it did not move further. So this is how we played around with the classes, objects, and the references. And one more important thing I wanted to mention, although I will mention it at the further class as well, that we have the structure for the class, a particular structure. So we can see that we have methods in both of these classes. Over here we have the public void show, and in the case of the demonstrate we have the main method. But we can define the attributes outside as well. Let's say if I could have written temp t4 or comma temp t5, so this way also we can initialize them. And this area where we are defining the attributes or fields, so these are basically the attributes slash fields. So we know them with both the names. And when we get to the functions, so these are the functions, or specifically known as methods in Java. So this is the main method and it is the function zone, and this one is the attributes which we define at the top. It's not necessary, but still we just try to keep the code clean and differentiate the zones. So this was the structure that a class, then it contains attributes and then the functions or methods. So let us just summarize and know the key takeaways from today's lecture. We got to know that how to create the objects of the class, although I showed it earlier as well, but today we played around with them as well. So we created the objects for our temp class. We got to know how to create the classes and how to call them from different class, and I have the main method in demonstrate, but I did not define it in the temp. And since I did not define the main method, I did not define the class public, because public class, only the public class contains the main method. Then we got to know how do we give the function or the method calls, and then we got to know how to create the on the fly objects, and they are very useful in the industry because they are much more efficient than these referenced objects. Then we did some assignments. From T1 to T3. We copied the addresses. We got to know how an address looks like. We printed those addresses over here, and then we again called some functions. So this is the basic concept of the referencing and the objects, and it is a very important concept. If we are clear about this concept, then it is very easy to learn Java, because Java and even the data structures are also based on this. Data structures also require a good knowledge of the referencing, because we have to play around with all these things only in Java. So that is it for today. I hope you liked the video, and if you have any queries related to the topic that we covered today, you can comment down below. And thank you very much for watching, and I will catch up in the next one.